Today on Tech Corner, we have got a product from Amada. This is a force gauge. Some of you may or may not know what a force gauge is. It is exactly what it says it is. It is a device, I'll show it on the other little camera up here, where when you push in on the plunger, it measures positive force in foot-pounds or pound-foots or kilogram-foots or newtons. If you pull on it, it does the same thing, except it just simply measures in the opposite direction. So regardless of whether you're pulling or pushing, it's measuring a force. Now this can be used in a lot of ways. It can be used as a simple go, no-go gauge for measuring force. It can also be used a lot of times for destructive testing and for measuring other things where the force varies over time, or where force ramps up to a certain point and then changes, and you want to map that. And I've got a couple of examples of how that works, and I'll demonstrate some of the features of this as we do it. So the first thing I'm going to do is I'm going to take a set of dictionaries here. These are the dictionaries we use here at Quality Digest. These are the 1956 edition of Webster's. Only the latest for Quality Digest editors.
They're vintage.
Yeah, they're vintage. Yeah, they got words in there that, like vamp and, words you just don't use anymore. Okay, so I'm going to turn to the software here. This software's got a lot of different features. One of them that is the most useful, and that we'll demonstrate here, is the ability to record a reading. So I'm going to set this recording, and what I'm going to do is I'm going to start pushing on this book, and we're going to look for where the frictional force between the books and the desks breaks, and then how much frictional force it keeps to keep pushing the book along. So we'll start at recording, and I'll start pushing against the book, and then we push, and 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 then it starts moving. Okay, so let's look at what this looked like. So what did we see? We're pushing against the book, and our force is ramping up, ramping up, ramping up. All of a sudden, it releases the frictional force on the books, and now it drops down. And now this force, this line right here on the right, this is how much force it takes simply to keep the book sliding against the desk, which is the frictional force between the dynamic force, frictional force between the books and the desk, whereas this is the static frictional force that you have to overcome. So another thing I'd like to show you is take our mouse here, and we're going to draw a little box around an area of interest. Let's say the point here where we broke the static frictional force with the desk. So what this is going to do is zoom in. So I draw a little box around my area of interest, and you see now we have zoomed in. And now that we're zoomed in, you can see that we can actually look at the individual points where the data was taken. Now with the Amada force gauge, we actually have the capability of taking data at up to a point every millisecond, or about 1,000 actual data points per second. And this is through the USB port. This is what Amada calls true USB. Very high throughput, actually. Now you'll notice that if I mouse over one of these points, we actually get a readout now of the force at that point, in this case 28.1 newtons, and where in our time scale this occurred, so in this case 9.728 seconds. And if we want to look at where the friction actually broke loose, we can see we actually broke free at 32.5 newtons. So this is pretty cool. This zooming function is really very nice. Let me do another one, which is probably a little bit more what you might see in a manufacturing environment, and we're going to look at a destructive test. Now this Amada force gauge comes with a number of different tips. I'm going to switch tips here. I'm going to switch tips to the tip that was...
It rolled off over there.
That rolled off...
No, I got it.
Oh, okay. Yes.
There you are.
Yes, there we go. Fortunately, that was there. Okay, this is just kind of a little pointy tip, and I'm going to use it. What we're going to do is we're going to test how much force does it take before this piece of tape. I'm just going to stretch a piece of masking tape, painter's tape, across the cup here. We're going to start recording, and I'm going to zero out the gauge here, and we're going to press, and the tape breaks. So we'll stop recording. Let's go back and look at that. So we see we ramped up, and we see at around roughly, I happen to have it on newtons right now, at a force of 12.7 newtons, the tape breaks. So let's see how repeatable that is. Now this isn't a very scientific setup we're doing here, but I would guess that it would be roughly in the same position.
12.7 newtons.
12.7 newtons. Let's do it again. So we'll zero this out. We'll start recording. And again, think of this as some destructive test you might do within your product. And we're going to press, and then it breaks. And we stop recording, go back, and hey, look at that, roughly the same, 13 newtons, okay? Isn't that interesting? So, did it roughly the same twice in a row. Let's double up the tape. This is 2 pieces of tape, one on top of the other. I'm just kind of curious what that's actually going to look like. Let's zero this out, start recording, and we'll go and press and press and press. There we go. Tape breaks. So what did we get? Did we get roughly twice, or?
Yeah, looks like it.
If I can get that out of the way. Yeah, we got up to, well, 26 newtons, so roughly twice what we had before.
Yep.
Who knows if that's really linear? You'd have to do 3 pieces and 4 pieces, but I thought that was kind of interesting. Now, one place where something like this might be used is, let's say you're a toy manufacturer and you make stuffed animals, and you want to measure, let's say, how much force it takes for an eye.
So it has like a hook.
Yeah. There comes a number of attachments. One of them might be one of the attachments is a hook, or you could probably machine your own. It doesn't really matter. You can zero this. You can always zero this out for whatever you're doing. So you hook a hook around that eye and start pulling and see what force it takes to break it loose. And maybe you have some standard. You require, has to be at least so much force in order to pass a test, right?
Right.
Now, I mentioned this works as a no-go gauge. I'll just show you this really quick. You can program into the software the upper limits and lower limits. And I'll just go up to this camera up here, Chris, just to show you, just real quick. You'll notice that there is a light on the left of the screen, which is, or your right, I guess, which is showing that we're below limit. Okay, now as I start to press, now you see the center light comes on, which means we're in between the low limit and the high limit, so we're in the good range. If I keep pressing, now the high limit light comes on your left. So now, what we've just seen is we've got a high limit, a low limit. Whoop. Oh, I had the peak on. Another function of this is it stopped at the peak. This also has a peak hold where it will hold the highest reading that you measure. So it's a very interesting little piece of equipment. The software is easy to use. They sent me a little video. I learned how to use this thing in like 5 minutes. The instruction manual is really small. I mean, seriously, this is really a shop floor tool that anybody could easily get up and using very quick. The data is exportable, I believe, as a CSV. So if you wanted to keep exporting data, do further analysis on it, you could do it. So that's an Amada digital force gauge.
Great. That's terrific. Well, thanks, Dirk. Thanks to the good folks at Amada for providing that to us. And we'll look forward to additional Tech Corners and additional shows coming up.